Okay, so I'm recording this. So if you need me to go, if you need to watch it to go over it again at a later time, you can. All right, so a particle moves along a horizontal line. Its position at any time t seconds is given by x equals that feet. So we have units, right? Feet and seconds, such that x double prime of t is less than 0 for all t. I threw that in there to help you so that you wouldn't have to take the second derivative. Okay. I don't even know if that's true or not. I didn't even take the second derivative to verify it, but I gave that to you. Okay. So that trumps whatever the second derivative. Okay.
I checked it and I was like,
All right. At what time was it negative?
I don't know. I didn't.
Yeah, you didn't need to. Yeah. Okay. So at what time does the particle change directions? Justify. So here's what we're going to do. A particle changes directions when the velocity changes signs. A particle changes directions when the velocity changes signs. We need the velocity function. So here's what we're going to do. X of t equals, I'm going to write this as t squared minus 2t plus 1 to the 1/2. Now, that one, I think, does factor into t minus 1 quantity squared. So if you wrote that as the absolute value of t minus 1, did anyone do that? You can, but that makes taking the derivative a little bit harder. We kind of threw that in at the end of the particle motion thing or the chain rule thing. And I said, if we were taking the derivative, we would run a line like this anyway. So I hope you left it like this. All right, so now we'll take the derivative. So here we go, x prime of t. Yeah, I'm gonna give you a check for writing x prime of t. That's what you need. You need that for sure. For sure. Yes. Oh, I was just gonna write that. dx dt. That also works. Fantastic. Now, you have the option of calling it v of t. That's the optional thing, all right? I would recommend doing that. And then here it is by the chain rule, okay? It's 1/2 times blob to the negative 1/2. So that's going to be t squared minus 2t plus 1. And I'm going to give you a check for that, okay? Because that's the first part, times the chain rule parentheses 2t minus 2. And then that's the third check, okay? Good, 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 good. Now, if you simplify that, there's a couple of ways. We got to get through this before the bell might ring, okay? You can either leave it as 2t minus 2 and then have a 2 in the bottom with the square root of t squared minus 2t plus 1. Some of y'all might have realized that the 2's divide out and you're left with t minus 1 all over just the square root of t squared minus 2t plus 1. I'm not necessarily going to give an extra check for that because really, I mean, I would encourage you to clean it up if you're going to use it, but it's not an absolute fundamental requirement. And I didn't tell you to clean it up. So, but those are the two easier to use versions. All right. So now here's what we need to show. We need to show that x prime of t equals 0 or v of t equals 0 or dx dt equals 0 or 2t minus 2 equals 0 or t minus 1 equals 0. Any of those are going to get the fourth check. Okay, any of those. And then you get t equals 1. Okay, now what do we do with t equals 1? That's just where the velocity is 0. That doesn't mean it has to change signs. But if you look at what the signs are, the bottom is always positive. So the sign of the first derivative is always following the sign of t minus 1. And instead of doing a number line chart, it might be easier just off to the side to think of what the graph of t minus 1 looks like. Here's -1, it looks like this, and then here's 1. So it does change from negative to positive. So here's what we're going to say then. By the way, this fourth check is for setting it equal to 0. All right. Any of those pieces. All right. So here's what we're going to say. Particle changes directions at t equals 1 seconds. Okay. I'm not going to really count units this time, but make sure you have units here. at t, there's not enough time for me to like address units. Just make sure you have them in the future. At t equals 1 second. So I'm going to give you a check for the answer. Okay. And then here's the justification. Okay, comma, because or since, either one, because of x prime of t or v of t, whatever you called it, right? X prime of t or v of t or dx dt changes from negative to positive at t equals 1 second. Okay. And that'll be the 6th check. So remember, you can't just say it changes signs. You got to say how it changes. College Board wants to know, and so do I then, how it changes. Okay. Comments, questions? We good? Cruising right along. At t equals, yeah, that's the 6th check, right? 1, 2, 3, 4, 5, 6. Okay. At t equals 0 seconds, is the velocity increasing or decreasing? Well, all we got to do is figure out what the acceleration is, right? So x double prime of 0, right? X double prime of 0 is less than 0. Okay, that's a given. I told you x double prime is less than 0. So x double prime is less than 0. Okay, I'm going to give that as a check. 6, that's number 7. You don't have to find the second derivative. And of course, you can call x double prime of t a of t if you want. The velocity is decreasing.
You did all the work. And then you have the negative value there as set equals
As-
negative, or as set.
As long as you have less than 0. Yeah, it's all about the inequality. If you did more work because you found the second derivative and you found the numeric value, that's fine. But it's all about the inequality. You need to say less than 0. And that'll be the 7th check. So velocity is decreasing at t equals 0 seconds. And again, make sure that you're always being thorough. You don't say it is decreasing, and you always reference the moment of time or the interval of time again. So that's preferable. X double prime of 0 is less than 0. Now, if you put x double prime of t is less than 0 for all t, that would also work because that encompasses 0. But it's a lot more poignant and direct when you just say x double prime is 0. You don't have to say the word given, but that was given up above. So the velocity or the particle's velocity, either one, is decreasing. And then you mention the moment of time again at t equals 0 seconds. All right. But I'll just take, if you just said decreasing, since x double prime of 0 is less than 0, that would be 2 checks. Okay. All right. Now at t equals 0 seconds, is the speed increasing or decreasing? Well, we already know. Okay, this is from above. We already know that x double prime of 0, which if you wanted to call it the acceleration of 0, if you haven't already, you could do that. Now I just need to figure out what the velocity of 0 is. So you take your velocity equation from way up here. Okay, and I'm just going to say x prime of 0 or dx dt evaluated when x is 0. Or if you called it v of t up above, v of 0 equals, and I'm going to plug it into the simplified version one, okay? So you get 0 minus 1 all over the square root of 1, which ends up being -1. Now, the fact that it's -1 is not so important. What's important is the fact that that is less than 0. So you need something to the effect of velocity is less than 0, or x of 0 is less than 0, or this is less than 0, but it's about the inequality again, okay? And then you would also need this to be restated. You can say from number 2 or from above, okay? So we're gonna call this all together. We're gonna lump that together as the 9th check. And then you would say, so the speed is, now if they're both negative, they're working together. That's the easiest way I can think of to help you remember it. Doesn't matter if they're both positive or both negative, they're the same sign, so they're working together. So speed is increasing, right? And again, you would say at t equals 0 seconds, but really If you just said increasing, that would be fine as well. Increasing, you're answering the question. That's the only question asked in that part. So you could say increasing since A of 0 is less than 0 and V of 0 is less than 0. That would be the most direct way. But remember, you don't use A unless you've defined A. You don't use V unless you've defined it. So you could just stick with since X double prime of 0 is less than 0 and X prime of 0 is less than 0. Okay, but we'll clump both of those together. Yes, Hank?
Is it increasing or decreasing? Why is it increasing?
Because the velocity and the speed are the same sign. Velocity is decreasing, but speed is increasing. And I chose them to be different on purpose.
Yes, sir.
Yeah. Okay. Yeah, I get it. You good. All right. So far, so good. Okay. Part 4. I don't know if you like this guy's name, but I thought really hard about giving him a cool name. If a second particle named the Marquis de Lerondre has a velocity given by W of t. I chose W in case some of y'all had chosen V for the other one. Tangent to the 5th of 3t, where t is in seconds and WT is in feet per second. What is the Marquis acceleration at t equals pi thirds? Include units and explain what the result means in terms of Lerondre's velocity. All right, so we need to know his acceleration at pi thirds. So the first thing we need to do is find his acceleration in terms of t. So let me go ahead and rewrite this. W of t equals parentheses, tangent of parentheses, 3t close to the 5th. And if you want to see a good execution of this derivative, you can look at Bendelay's paper. I just happened to walk by. He was in the front row. And man, he had some boss multiplication dots there. And I liked it. Okay. So here we go. W prime of t. I'm not going to call that A of t because I've already used A up above. So you would call it something else. But anyway, try not to reuse the same letters, right? If you called the acceleration up above little a, then you would want to call this one just W prime or capital A or something like that. So it's 5 blob to the 4th, and we get tangent of 3t. So that's one of the links in the chain. So that's going to give you, oh, I need to give you notational credit as well, because that's also important. So this will be the 11th check. And then this is the first link in the chain. And then I'll do like Bendelay, make that a boss multiplication symbol. I like it. And then we go to the inside. The derivative tangent of blob is secant squared of the blob, with or without parentheses around the 3t, right? There's the next link in the chain. So that's the 13th check. And then times another boss multiplication times 3. And that'll be the 14th check. Okay. And of course, now if you want to simplify that, feel free. But I'm just going to plug in a pi thirds. So W prime of pi thirds equals, and notationally, we got it as another check. So again, Zechariah, you can have a dW dt if you did Leibniz notation here. Oh, okay. All right. And then dW dt evaluated at. Okay, so I'm just going to plug in. So we're going to get the 5. That becomes tangent of pi, right? Tangent of pi, which dang is what? That's going to end up being 0. That's not going to be good. Okay, anyway, to the 4th times secant of pi squared times 3. And man, if you left it like that, that's good. We'll call this the 16th check. But of course, it simplifies. Tangent of pi, unfortunately, is 0. And that wipes everything out. So 0 feet per second squared. Okay, but we'll still count that as the 16th check. That was an unintended consequence. I was doing this quickly in my head, and I wanted to choose an angle that made secant nice. Secant of pi is -1, but I forgot the tangent was still going to be there. So What does it mean in terms of Lerondre's velocity? At t equals pi thirds seconds. Check, that's the 17th check, comma, the Marquis, I'll just call him the Marquis. The Marquis's velocity is neither increasing nor decreasing. Okay, and you could stop there, or okay, you could say that, or you can say is increasing by 0 feet per second, or you could say decreasing by 0 feet per second. I'm not going to even give this a check because it was an unintended consequence. What is constant? Oh, yeah, or you could say his velocity is constant. Yeah, we'll just talk about it, but I wanted it to be a positive or negative number. So anyway, we won't count off for the sentence here. So we'll just say that either one of these answers, and again, I'm not going to count the units in this case. So we got 16 checks. I think that's right? 17 checks? If I don't count the sentence at all. I took that one away. Yeah, I took that one away. Yeah, because it's part of the sentence. And yeah. 16. Yeah, go ahead.
So if I plugged in the pi thirds, are you giving that as a check or are you giving the 0?
Yeah, the notation is the check. And so is getting the numerical answer, simplified or unsimplified. Yeah. Yeah.
If we did do like, we changed it to like V of T or A of T, would that be wrong?
No, but you have to define that. Yeah.
Yeah, but we did it on like the problem before.
Yeah, if you called it A of T again, then I don't take off this time, but you don't want to have two different functions being called the same thing. Yeah. Yes. On which part? There are 3 points apiece. Subtract 3 for every check you did not earn from 100. On number 3? Number 2.
Because it says it's the first increase. So wouldn't it be x time of 0?
No, that just tells you what the velocity is. That tells you if the position is increasing or decreasing. To determine if the velocity is increasing or decreasing, here's the deal. To determine if any function is increasing or decreasing at a moment, you look at its derivative. So if I want to know if velocity is increasing, I need to look at its derivative at that moment. And the derivative velocity is acceleration. If you just look at the velocity, it tells you if the position is moving,
So if
changing.
I got that part wrong on it, but then I still said it's decreasing at whatever I found here, do I get that 80 check?
Yeah, see, because then you're answering it in position units. The velocity is I'll give you credit for saying decreasing to the 8th check. Yeah. Here, let me stop the recorder then. All right, so that's all we're going to do today.